Leia May P. Babagonyo. Objectives. At the end of this lecture, student will be to define and distinguish what is comprehend about its type and classification by means of provided example.
Hi, good morning to Mom Rochelle and good morning to my classmates. I hope all is well. So my name is Rodwy and I'm from Group 2 Reporter. I will give a brief introduction towards our topic, which is set. Alright, so based on Google, particularly in Wikipedia, considering a set in mathematics is a collection of elements. It is an elements that make up a set, which can be any kind of mathematical objects such as numbers, symbols, points in space, lines, other geometrical shapes, variables. Alright, so the set theory originated from the work of George Cantor, where his work was separated as a mathematical discipline between the years of 1874 until 1897.
Greetings everyone, my name is Niloy Mbaks III and this is the report of Group 2. Deepening and emphasizing discussion. Sets are denoted using a simple notation. Just list each element or member separated by comma and then surround it with curly brackets, or also referred as set brackets or braces. Now, this is the notation to provide you an examples. Open curly bracket, socks, comma, shoes, comma, watches, comma, shirts, and so on. Then close curly bracket. Second example. Open curly bracket, index, comma, middle, comma, ring, comma, pinky. Then close curly bracket.
Numerical set. So what does we have to do with mathematics? When we define a set, all we have to do is specify is a common characteristic to say we can't do so with numbers. Set of even numbers. -4, -2, 0, 2, 4. Set of odds numbers. -3, -1, 1, 3. Set of prime numbers. 2, 3, 5, 7, 11, 13, 17, and so on. We can came up with all different sets. We can also define a set by its properties, such value of x greater than 0, which means the set of all x such that x is greater than 0. Universal set. At the start, we use the word things in quotes. We call the universal set. It's a set that contains will not expectly everything that is relevant to our question. In number theory, that is all the integers, as number theory is simply the study of integers. But in calculus, known as real analysis, the universal set is almost always the real number, and in complex analysis, you guess it, the universal set is the complex number.
Hi, my name is Lovie F. Barrera, and my part is to tackle about equality, subset, and proper subsets. Equality. Two sets are equal if they have precisely the same members. Now at first glance, they may not seem equal, so we may have to examine them closely. Example. Are A and B equal, where A is the set whose members are the first four positive whole numbers, and B is a set whose members 4, 2, 1, 3? Let's check. They both contain 1. They both contain 2, and 3, and 4. And we have checked every element of both sets. So yes, they are equal. And the equal sign is used to show equality. So we write A is equals to B. Now for another example, are these sets equal? A is a set whose members is 1, 2, and 3. And B is a set whose members 3, 1, and 2. Yes, they are equal. They both contain exactly the same members 1, 2, and 3. It doesn't matter where each member appears so long as it is there. Subsets. When we define a set, if we take pieces of that set, we can form what is called a subset. Example, the set 1, 2, 3, 4, 5. A subset of this is 1, 2, and 3. Another subset is 3, 4, or even another is 1, and etc. But 1, 6 is not a subset since it has an element 6 which is not in the parent set.
Hey guys, good morning again. My name is Broadway. I'm gonna tackle about now the empty or null set. So this is pretty simple. It's basically from the word itself, empty. Okay, so let me just cite an example for you. Think of a set of a piano case on a guitar. So as you notice, there's no piano case on the guitar, right? So basically, this empty or null set is a set that contains no element. Okay, it can be written this. Alright, so that's what we call empty or null set.
Empty sets and subsets. So let's go back to our definition of subsets. We have set A. We won't define it any more than that. It could be any set. Is the empty set A subset of A? Going back to our definition of subsets, if every element in this empty set is also in A, then the empty set is a subset of A. But what if we have no elements? It takes an introduction to logic to understand this. But this statement is one that is vacuously or trivially true.
Okay, good morning. Rodney again from Group 2 Reporters. So, alright, let's talk about cardinality of set. So, the number of elements in the set is the cardinality of set. Okay, let me just give you an example. Let A is equal to 1, 2, 3, 4, 5, and 6. So, that is the element of the A. And B, the element of 2, 4, 6, 8. Alright, so here's the question. What is the cardinality of B, A union B, and A intersection B? So, first the answer. The cardinality of B is 4 since there are 4 elements in the set, as you can see that. The cardinality of A union B is 7 since A union B, which contains 7 elements. The cardinality of A intersection B is 3 since A intersection B, which contains 3 elements. So that's pretty basic what we call cardinality.
Why are sets important? Sets are the fundamental property of mathematics. Now, as a word of warning, sets by themselves seem pretty pointless, but only when we apply sets in different situations do they become the powerful building block of mathematics that they are. Math can get amazingly complicated quite fast. Graph theory, abstract algebra, real analysis, complex analysis, linear algebra, number theory, the list goes on. But there's one thing that all these share in common: sets.
Hello everyone, by the way, this is Ayuban Dennis B, BSED-MATH as Set A. In this point, I will give you the total summary towards our topic for today, which is set. What is set? Well, a set is an unordered collection of objects. For example, the students in this class, or the chairs in this room. The object in a set are called the elements, or members of a set. A set is said to contain its element. And now, here are the special sets. Standard notations used to define sets. Set of all natural numbers. Set of all integers. Set of all rational numbers. Set of all real numbers. and set of all complex numbers. And now, here are some types of sets. Subset, equal sets, empty sets, singleton set, finite set, infinite set, cardinal number of a set, power set, universal sets. Once again, this is Ayuban Dennis B, BSED-MATH Set A, greeting you a warmest day. Thank you.